Alabama STEM Explorers is made possible by the generous support of the Hudson Alpha Institute for Biotechnology, Southern Research, solving the world's hardest problems, the Hawley Family Foundation, Alabama Works, Alabama STEM Council, Alabama Mathematics, Science, Technology, and Engineering Coalition, Alabama Math, Science, and Technology Initiative.
Wow, a chocolate cake. I can't wait to eat some of that. But I just finished eating and my stomach feels full. I don't think I can eat another bite. But still, it is cake, and I love cake. I feel like if I eat another bite, I'll explode. Why did I have to eat that apple? And why can't I eat any more food? Is my stomach all full of apple? Is that possible? I know where I can find the answer. Come with me.
And welcome to Alabama STEM Explorers. We're here at Alabama State University, and I'm here with my friend Cruz.
Hey.
Cruz was just telling me about some food that he had. I think he had a slice of chocolate cake, was it?
Yeah, it was really delicious. It looked really delicious, but I couldn't eat anymore because I was really full.
Oh, wow. You're probably really full because your body needs time to digest your food. And if you had already had a meal prior to that, chocolate cake probably just was going to put you at the edge. So what we're going to do, we're going to look at how food moves through our body through this demo. And so it goes through an action called peristalsis, where it's going to show how our food moves through our body. So I took the measuring tape and I went ahead and helped you by counting off how long everything is. So we use the centimeter side. All right. So let's just read off how long the mouth is. The mouth is what?
11 centimeters long.
Our esophagus is what?
25 centimeters.
Our stomach is
22 centimeters.
And I think I'm gonna need your help as we go to this to the small intestine. Let's see. Oh, we're still going. Oh my gosh, how long is our small intestine? Have we gotten to the end yet? No.
It's so long. The small intestines.
Yes, a lot of digestion takes place here. And how long is that?
690.
Wow, that was really long from you thinking about the distance of our mouth and the esophagus till we get to there. And how long is our large intestine?
152.
Yeah, 152. So it's not as long. And then the very end, this little short piece is our what? Rectum.
Sorry, I was reading this.
And it's how long?
14 centimeters.
14 centimeters. So we're going to demonstrate how this process occurs. So digestion first begins in the mouth, and it begins with the use of enzymes. And enzymes help to speed up chemical reactions that occur in our body. And it starts with an enzyme known as amylase. So this tennis ball is going to represent food, and we're going to look at this process. So I want you to put that tennis ball into here.
Which is the mouth.
Yes, it represents the mouth.
Okay.
You might need a little help.
Yeah.
You got to force it down. Let's try that again. Okay. All right. So we have this tennis ball to represent the food that's going to move through the process.
There we go.
Oh, great. Okay. So I just want you to move it from the mouth to the esophagus.
Okay. Now you just
That was pretty simple, right? So at this time, we know that we have to have enzymes and we have to have other digestive things within our body that are going to help in the process of digestion.
Like fluids.
Yes. And so this right here is oil, and we're going to use that to represent mucus.
Okay.
So, some people may say, ew, that's kind of yucky. But, it's our bodies. It has to go through a process. So we're going to pour this down into our bed. Yes, if you could just help me.
There you
So
go.
it was pretty easy pouring it at first, right?
Oh, that's a lot of mucus.
Yeah, let's see how easy it is now to move this down to the stomach area.
Oh, it feels so weird.
Yes. Why do you think it feels like that?
Because mucus is like slimy.
Yes, but see, what happens is you have these muscles that are within your stomach that help this process. So this will kind of give you a better feeling of like they're moving back and forth to get this process. So here we are, moving down. We've gone through our mouth and our esophagus. Now we're in our stomach. Let's see, let's move on down. Now we're getting into that small intestine.
The really long one.
Yes, and so it's not as easy moving it through, is it? Oh, right. So we're moving down through there. So this food, every time you eat, your body goes through this process. And can you thinking about the length of the small intestine? Can you imagine how it is in your body? So what happens? It has to be what? We can stop for just a second. It's what? How you think it's inside of your body? Because, I mean, you're not 690 centimeters long, are you?
No.
So how do you think that small intestine is inside of your body?
It folds.
It's folded up, yes. And so there are different parts. It folds like this within your stomach area, your abdomen, and so that it can do its work. And so that's why we have, like, you know, we're showing how long it is to let you know that that process of digestion has to occur.
Yep.
And so it does not like soon as you eat, your food is automatically digested.
Yeah.
It begins in the mouth and it goes through an entire process. And so the muscles help control your digestive system and those digestive enzymes, or sometimes you may see digestive juices that are helping your body go through this process. And so here, we'll let some more of that oil go down. So now do you understand why you probably couldn't eat that cake?
Yes.
Why? Why do you think you couldn't eat it? Because your body still had to go through what?
The digestive system.
Yes.
The digestive system.
Yes, it had to go through all of these processes. And so here we are. Hold on, let's get some of that.
Yeah.
Okay, push it on down there. So we're still moving. And just thinking about how long this is taking us just with our hands.
Yeah,
So think about how long it's going on in your body.
How long does it take?
Food digestion process is going to take a couple of, it's not as long as you think it would be. It's not like hours and hours, but it does take a significant length of time. But the enzymes are going to be responsible for helping that process occur. Enzymes are catalysts that help speed up chemical reactions. They're also known as proteins in that macromolecule group. So here we are still moving through this process. And then once we get down to the, see now it's getting a little tighter there, right?
Here,
and
wait.
so, yes, we have
Let's
to
unfold
move
it.
Yes.
Okay, now.
And then we're still moving that through. So we have to get it down to where the food is broken down, the process of the food breaks down in our body, and then what do we have to do? We release it out as what?
Poop.
Yes, as poop. And so we have to release out our poop or our feces as we defecate them out, and that allows anything that needs to be absorbed in our body was absorbed for nutrients, and the excess is released out as waste. And it goes all the way down to your rectum and out of your anus.
And we're finally
at
the large intestine.
Yes. So we have to be very careful. You can't eat too much food at one time because then you got to think about this long process that your body has to undergo just to digest food. So
what happens if there's too much food?
If there's too much food, sometimes your body may not make it all the way down that process, and then you might actually regurgitate it back out right through this area and it comes back out your mouth. So when you vomit, that's regurgitation. That process has moved it back up and it did not make its way down the full digestive system. I think we're good right here. You're almost at the end and we'll release this out. So next time you know, you got to eat your food and chew it well and wait for it to what?
Digest.
Digest.
I've always loved science and math, but I didn't quite see a career where I could put it into place where I could really help people to actually do the work for themselves. So I wanted to empower people to care for themselves. I thought medicine at first, but then I got to meet a registered dietitian and the light bulb went on, because we get to do math, we get to do science, we get to do research, we deal with technology, we do it all. I specialize in diabetes. So one thing about diabetes is we're very concerned about the carbohydrates. You can eat them, it's just how many you have at a time. There are so many apps that help you to find restaurants. They calculate calories, calculate carbohydrates. So anything you eat, you have cheeseburgers, chicken sandwiches, your favorite foods, they've already done the science and the technology behind it so that you can have the calories, the protein, the carbs right at your fingertips on an app or on a website. So, I mean, now we're realizing how nutrition and health affects so much. So we're really able to have access to that, and then my clients and patients have access to that. I would say explore the options. You know, there's so many options that we don't necessarily see. We see doctors, we see nurses, we see scientists, but there's so many other ways that you can do those things and so many different careers. So start looking, you know, aerospace, looking into health in different ways. You know, I'm actually able to also teach college. So I'm a professor at Tuskegee University while I'm also a registered dietitian. So I really get to do all of these amazing things with the same title. So it's pretty neat. I would say explore all of those options.
Hi, I'm Nilah, and I'm here with Neil at the Hudson Alpha Institute for Biotechnology. So, I hear some people talk about how foods give us energy, but what does that mean?
That's a great question, Nilah. So, all foods, candy bars, apples, oranges, steak, all are made of molecules. And those molecules are held together by chemical bonds. And there's energy contained in those chemical bonds. When we eat food and we digest it and send those nutrients to our cells, the cells actually break the bonds and capture the energy that's released, and then use that for things like cell growth and development.
So do all foods contain the same amount of energy?
They don't. Some foods contain more energy than others. Some foods contain energy that our cells can get to quickly, and some foods contain energy that takes longer for our cells to process. Food scientists measure the amount of energy in food using a measurement called calorie.
Calories. I've heard of those. They're listed on food packages, right?
That's exactly right. Almost all food packages list somewhere how many calories there are in a specific serving of that food. Scientists actually figure out calories by looking at the energy that's released when the food actually gets burned.
Burn food?
Burned food. I know normally that's not something that would be very appetizing to any of us.
No.
Food scientists use something called a food bomb, which just sounds really cool and a little bit freaky at the same time. They take the food, they dry it down, and then they put it in an insulated container, and then they catch it on fire. And in this container, there's a vessel of water and a thermometer. And the energy released from the food in the fire heats the water, and then they can measure the increase in temperature with the thermometer and then work backwards to figure out how many calories, how much food energy is in food.
Wow.
Would you like to make our own food bomb that's not really a bomb?
Sure.
Okay, let's try that. So, this is the experiment. This is the materials that we're going to use. We're specifically going to measure the energy that's in a sunflower seed and a miniature marshmallow. Now, when food scientists do this experiment, they control lots of different variables. Do you know what a variable is?
Something that can change an experiment?
Exactly. There are lots of things that could change in this experiment. The amount of food we use, the way we set it on fire, how much water we use. They're very, very precise. They control all those variables. You and I are not going to control all those variables. Our data is going to be a whole lot less precise.
Okay.
So let's start. Sunflower seed, miniature marshmallow. Now, we don't eat the outer shell of the sunflower seed.
Right.
At least I
don't eat that either.
Okay. So we're actually going to use the kernel. Now, that's the size we're going to use against our miniature marshmallow.
Okay.
Can you think of a variable that we need to try to control between these two?
They're completely different sizes.
Totally different sizes. So we need a piece of the miniature marshmallow that is about the same size as the sunflower seed kernel. That's what we're going to work with. Just like our food bomb, here's our piece of food on a pointed holder. We've got a tube with 20 mils of water in it and a thermometer. You're going to set the food on fire. Well, actually, before we do that, yes, you're going to set the food on fire. That's probably not something you hear every day. Please set the food on fire.
No, I never hear that.
You don't ever toast marshmallows?
Oh, okay. Yeah, when I make s'mores.
But somebody probably doesn't say, please go set the food on fire
No.
for that. They say toast marshmallows. We're going to measure the temperature of the water before we get started.
Okay.
And then you're going to set the marshmallow on fire, and I'm going to move it under. We're going to let it burn, and then wait 10 seconds, and then check the temperature. All right. This is an issue that we need to talk about safety. Because we're working with fire, this is an activity that needs to be done under supervision and in a lab. Don't try this on your own. We've got water available in case we need it. The pie tin will catch any flaming food that drops, and Nilah and I will both be wearing goggles. So let's go ahead and put those goggles on. And I'll pull our whiteboard to track our information. Go on ahead and check the temperature.
Okay. The temperature is at 22 degrees Celsius.
Okay. 22 degrees Celsius is about 70 degrees Fahrenheit. All right, are you ready to set the food on fire?
Yes.
Okay, you're going to light it and hold the flame just below the marshmallow. There we go.
Whoa.
Yeah,
It's getting like bigger and smaller.
and bubbly, and now charcoaly.
It smells good though.
It does. It smells like toasted marshmallows. Maybe it smells a little bit more like burnt marshmallows, but still, it has a nice smell. Okay, it's been about 10 seconds. Go on ahead, and what's the temperature of our water now?
Now it is at 25 degrees Celsius.
Okay, so the burning marshmallow raised the temperature 3 degrees Celsius. The food energy in that marshmallow has been turned into heat that we've captured. So now let's swap and let's try it with the sunflower.
Okay.
So I'm going to go ahead and put this new vial of water in, and I'm going to have you read the temperature.
Okay, it is at 22 degrees Celsius.
Okay, will you hold that, please?
Yes.
22 degrees. So same temperature. And that makes sense because they're both sitting out at the same space. All right, now let's put our sunflower seed kernel in here. And then let's adjust it so that it's going to be right underneath the flame. Okay, ready to set some more food on fire?
Yes.
Let's go. And this might take a little bit longer to catch fire. There we go. Right underneath.
It's definitely not changing shape.
No. It's burning a lot longer,
Yeah, starting to smell.
and now it's out. That burned a little bit longer than the marshmallow, I
Yes.
think. And it now smells like burnt popcorn in here. Not good. Okay, going ahead and see what the temperature of our water is.
25 degrees Celsius.
Okay, so let's move this out of the way and let's talk about our results. So what was the temperature increase for the marshmallow?
3 degrees.
And the temperature increase for the sunflower kernel?
3 degrees.
All right, so at least based on this data, it would look like they both have about the same relative level of food energy.
Right.
But based on what we saw when we actually saw it burn, do you think that they seem to burn in the same way, or did they burn differently?
They burn differently. The sunflower seed burned longer.
It did, and it seemed to have a bigger flame as well. Remember, we talked about variables. These are things that can change in an experiment. And there are a lot of other pieces that we didn't necessarily capture. So even though this would suggest it's the same amount of energy, some of the other visual pieces might suggest maybe there's a little bit more energy in the sunflower seeds. And if we actually read the package This is a serving of miniature marshmallows and a serving of sunflower seeds, 30 grams each. There are almost twice as many food calories in the sunflower kernels than the miniature marshmallows. So there is more food energy from the sunflower kernels. So when you ate breakfast this morning and your body started burning up your food, by the time you got to lunch, what do you think had happened?
It was stored energy.
You had probably burned through much of the food that you had started burning through the food that you had eaten. Your stomach was empty, we were hungry, your body was saying, hey, I need some more food, I need to create some more energy from that food.
Right.
Now, when we eat food, it does not burst into flame inside our body. That is not the way this works. The process of breaking those chemical bonds is much more controlled through a process called cellular respiration. But the same thing happens. We broke apart and got energy from fire here. Your body, those enzymes, break that apart. That's a pretty cool set of lessons from a food bomb, sort of.
Yes, very interesting.
At the Stitt Restaurant Group, we have Bottega, Chez Fonfon, even in Highlands. But here we are at Bottega, and you can see our wood-burning oven where we roast fish, we bake pizzas, all kinds of things. But what is one of the most important aspects of my job is working with local farmers to get the greatest ingredients. And now with a lot of the new generation or younger generation of people that have been able to farm successfully, that we have never had such great produce and such nutritional food that's coming from central Alabama. We are so fortunate to have Jones Valley Teaching Farm here in Birmingham, and it is a leader across the nation in teaching kids about the biology, the math, and science that has to do with farming, of planting and growing and harvesting fruits and vegetables right there on their site, downtown Birmingham. And so people from all over the country are coming to learn that what Jones Valley Teaching Farm is providing for the school children of Alabama. And it is fun to learn about how good a carrot can be for you nutritionally, as well as sweet and delicious, especially when you use the science to get the soil that is rich in all the biology that helps farming to be successful. And so I'm very excited about Jones Valley Teaching Farm. At the end of the day, when you're working with the land, you're working with produce, you're able to provide sustenance, you're able to provide health to people, and you can make money by being a farmer. You've got to study, you've got to use science, you've got to work hard. Nobody said it's going to be easy, and the same thing about being a chef. But it's something that you love, you enjoy the process, and at the end of the day, you get to break bread with people that you care about.
Hi, my name is Carmen, and my question is, why is the color of a flame yellow or orange?
What a great question. Flame color depends on two things, the temperature of the flame and the material being burned. These colors indicate the presence of unburned carbon compounds. As the fire burns, some of the unburned carbon compounds are released into the flame rather than fully igniting. The end result is an orange or yellow colored flame.
Thanks for watching Alabama STEM Explorers. If you missed anything or you want to watch something again, you can check out our website at alabamastemexplorers.org. Maybe you have a question we could answer here on the show, and you might grab a cool t-shirt. Feel free to send us a video question or an email on our website, alabamastemexplorers.org. Thanks again for watching. We'll be back next week. Alabama STEM Explorers is made possible by the generous support of Hudson Alpha Institute for Biotechnology, translating the power of genomics into real-world results. Southern Research, solving the world's hardest problems. The Hawley Family Foundation, established to honor the legacy of Brigadier General Everett Hawley and his parents, Evelyn and Fred Hawley, champions of servant leadership. Alabama Works, a network of interconnected providers connecting business and industry needs to a highly skilled and trained workforce. Alabama STEM Council, dedicated to improving STEM education, career awareness, and workforce development across Alabama. Alabama Mathematics, Science, Technology, and Engineering Coalition for Education, advocating for exceptional STEM education in Alabama. Alabama Math, Science, and Technology Initiative, the Alabama Department of Education's initiative to improve math and science teaching statewide.